Hi dear students, let's see this question that came in JEE Advanced Paper 2 Physics in the year 2019. The question was fairly simple from the topic of motional EMF and LR circuits. Most of the students would have done this question quite comfortably. So let's see what's happening over here. There's a rod of length 10 centimeters which is moving at a constant speed of 1 centimeter per second in the presence of magnetic field of value 1 Tesla, and the magnetic field is perpendicular to the plane of the screen. At a certain instant, this switch is closed. The resistance is 1 ohm, the inductance is 1 millihenry. So because when the switch will be closed, there will be flow of the current because of the induced EMF. So we have to find the value of that current at the instance of 1 millisecond after the closing the circuit. We have to represent our answer in form of x into 10 to the power minus 3 amperes. So X will be our answer. So basically we have to find the current in terms of milliamperes, and that itself will be our answer. Now first thing we need to realize over here is that there must be some external agent, otherwise this rod cannot move at a constant speed. Because when the current will start flowing, because of that current, this magnetic field will start applying the force on this rod, and hence the speed of the rod will slow down. But since it's in the question, it is given that speed remains constant, therefore there must be some external agent. Although we don't have to be bothered about this because it's not going to harm us. Like we don't need to be concerned, but it's just that for the clarity's sake, I told you. So let's find the value of the induced EMF. That will be BVL, right? Because magnetic field, velocity and length are all mutually perpendicular to each other over here. So we can simply multiply these three terms. So magnetic field is 1 Tesla, velocity is 0.01 in meters per second, and length of the rod given was 10 centimeters, which will again become 0.1. That means the induced EMF will be 10 to the power minus 3. We can also see the polarity of the induced EMF. It will be like this because higher polarity is always in the direction of velocity cross, like cross product of velocity and magnetic field. So if you see V cross B, it's going to point in the upward direction. So this is the higher polarity. Now, this becomes a LR circuit. So we already know the current in the LR circuit can be written as I is equals to E by R into 1 minus e to the power minus t by tau. Tau is nothing but L by R. Okay. So just put the values 10 to the power minus 3, resistance is 1. The time at which we have to find the current is 10 to the power minus 3 only, milliseconds. Inductance is 10 to the power minus 3 and resistance is 1. So this value becomes e to the power minus 1, which was given to us as 0.37. So always remember, this is a hallmark of a good paper, that they will ask less calculations and more concepts. So this is 0.63, and hence we can say that current in milliamperes is nothing but 0.63 itself. So X will be equals to 0.63. So very simple question. I hope you would have understood. That's it. Thank you.